Hi guys, welcome back to Cloud Folklore, where we'll unravel the mysteries of digital sky. I'm Goodness Ebel, and today we'll be diving into Docker. Well, not the whole of Docker per se, we're just going to be talking about Docker images, right? I'll show you how to build a Docker image from scratch using a Docker file. We're going to make it multi-platform so it can run on any OS of our choice. We'll push it to our Docker Hub registry, of course. Then right at the end, we'll be talking about build contests. Let's dive into it. Cheers. Before we dive into creating a Docker image from scratch or writing a Docker file, let's quickly look at what Docker is all about, and why it's so popular. Docker is an open platform designed to help developers build, ship, and run applications in lightweight and portable containers. You can think of these containers as isolated environments that bundle up your application code, dependencies, libraries, and settings all together, making it easy to deploy your application across different environments without worrying about compatibility issues, right? You can run you can run the same Docker container on any environment, whether it's a laptop, a cloud provider, a server. You can run it anywhere without any changes, right? Docker ensures that your app runs the same way in every environment, be it development environment, be it production environment, reducing that dreaded "it works on my machine" problem. Um, Docker containers are also lightweight and they use fewer resources compared to your traditional virtual machines because they share the host kernel while remaining isolated. Now, I won't go deeply into explaining what Docker is all about because I would assume that you have base knowledge of Docker before jumping into this tutorial, right? This tutorial mainly is to show you how to create a Docker image using a Docker file. But of course, I will digress a bit and talk about important stuffs, right? Now let's talk about Docker containers. Now, a container is like a lightweight virtual machine. It provides an isolated environment where your application and its dependencies, you know, can run, but without that overhead of having a full-blown operating system like a virtual machine, right? Containers share the host machine's kernel, but keep your app isolated in its own environment, meaning that you can run the same container on different machines and to behave exactly the same way. You don't have to worry about spinning up a virtual machine that consumes way more resources and it will even take more time to spin up and configure, right? Now, a Docker image is like a blueprint for that container or for a container. It's a read-only file that contains everything your app needs to run, like the code, the libraries, the dependencies, the runtime environment, anything at all that the app needs to requires to run. Now, when you run an image, Docker creates a container based on that image. This is why it's so useful. It helps with consistency. And these Docker images can be shared across different systems, meaning you can develop on your local machine and run that same app on a cloud server without any issues if you configure it right. Now, let's talk about Docker files. Now, a Docker file is a simple text. It's a simple text file that contains a set of instructions on how to build a Docker image, right? Now, think of it like a recipe. It tells Docker which base image to use, what dependencies to install, how to configure the environment, so that your app can run inside the container perfectly well. Let's go further. Now, before you can build and run a Docker image or Docker containers, you need something installed on your system that would allow that to happen. It's called a Docker engine. Now, you can view a Docker engine as that core service that allows you to build and run your Docker containers. Now, if you're using a Windows or a Mac OS, you can install something called Docker Desktop. It will provide both the Docker engine and a GUI, a graphic user interface, for managing your containers and resources within Docker. Now, if you're using Linux, you can install the Docker engine directly using distribution package manager like apt for Ubuntu and Yum for CentOS. So let me quickly show you what the Docker engine looks like. So let me quickly show you what the Docker desktop looks like. Well, I'm using a Mac. I'm quickly going to spin up the Docker desktop so that we can run Docker commands. Yeah, so this is what you can see starting the Docker engine, containers, images, volumes, those stuff. So the demo is not about showing you how Docker desktop work. I just wanted to spin it up. So let's get back to the tutorial. We're quickly gonna run a command, Docker. Yeah, so it's working. You can see Docker. This shows me a list of running containers. I think I should stop this though. Docker stop. Take the container ID. Yeah, that's stopped it. That's just stopped it. Then they're running out. Great. Yeah, you can also run Docker images command. Yeah, so um let's continue. Now let's talk about Docker Hub. Docker Hub is a cloud-based registry where you can store and share your Docker images. Now you can think of it as GitHub for Docker, right? It's the most widely used container registry, and it comes with several useful features, right? You have your public and your private repositories, just like on GitHub. You have image versioning, and also Docker provides us with what you call official images. Now, these official images are pre-built, and they are highly trusted images for popular softwares like Node.js, Python, MySQL, and more. Which you can use as like a base image when you're building your own container. So you don't have to build base images from scratch. For example, now we're going to build a Node.js Docker container, right? For our application. So we might as well utilize the base image provided by Docker, which is a Node.js base image, right? We'll go more into base images when we start creating um the Docker file. But I just wanted to highlight what Docker is. Well, this is the environment. We can quickly touch around. This is my personal account. These are the repositories I've created. I can make repositories private and public. You have organizations as well. Yeah, so we won't go deeply into exploring Docker Hub because I want to keep the video as short as possible and fully focused on um the Docker image or Docker file that we're creating. But these are official images. You can see Bash, you can see MySQL, you can see Nginx, you can see BusyBox. Yeah, so these are like official images. You can see I think there's Node.js somewhere around here. Maybe if you search for it, you definitely see, but these are mostly official images. Yeah, so let's move forward. Before we go on to packaging our application into a container, let's actually know what we are packaging, right? We don't want to make that mistake. So this is a very simple Node.js application that uses Express for handling HTTP requests and Mailchimp's API for managing um, newsletter subscriptions. So basically, you put in your first name, put in your last name, put in your email, and voila, you get subscribed to an email, to a newsletter. So let's look at the code base quickly. Let's view the app.js file. So um, I don't really want to go deeply into explaining the whole code base. So basically, um, Express is used to set up the web server. The body parser is used to pass incoming data, to pass incoming data from the Mailchimp API is used to interact with this is used to interact with the API, or rather the Mailchimp client is used to interact with the API and manage email subscription. The env required here is to load environment variables, because of course you would not want to explicitly define your Mailchimp API key and server here. So it's in your .env file. So let's just quickly spin up the application. We don't need to go through the whole code base because that's not important. Node app.js should spin up the application. Yeah. So let's visit it. Let's quickly spin up Brave a window. Yeah, so local host 3000. Yeah, so let's subscribe. Okay. Um, let's add a new subscriber to our newsletter, right? Let's add Johnny Bravo. Right. Johnny is a fan. So let's add him to our newsletter. We'll talk about cool gene tips. Yeah. So at gmail.com. Yeah, great. So Johnny has been signed up. Now let's imagine someone tries to use Johnny's email again to sign up. So springs up an error. Email has already been subscribed. So has already subscribed rather. So even if you use a false email, it's going to give you an error, right? So now we can see the application is running fine locally. So let's package this application so I can run anywhere. And of course, we're going to put it on Docker Hub. Let's do that. Let's move into creating the Docker file. Again, this is the code base of the application itself. We've tested that. Now let's package this application so that we can have a containerized version of it. The first thing you want to create is your Docker file. So the Docker file has no extension. It's just called Dockerfile. There's no .js or .docker or .doc. It's just plainly Dockerfile, just like you have Procfile for Heroku. Next, let's populate the Docker file with important information. So these Docker files can be seen as sets of instructions, right? It's like a command or sets of they're arguments, right? But I like to see them as instructions that you are passing to Docker. You're telling Docker, do this, build this from this, build that from that, right? Copy this, right? There are sets of instructions. I like to see it that way. So the first instruction we're giving Docker is telling it this. Now the argument part is normally denoted in encapsulators, but I think from my experience, it doesn't have to be encapsulators. I think it will still run. If I said from, or as a standard, just place it in all caps because that's the standard. So I'm going to be using, first of all, I'm going to tell Docker to get me a base image, which I'll build my own Docker image on top, right? Basically, what this line tells Docker is to use a base image as a starting point for our container, right? Now, a base image is like a template that provides the essential system and runtime environments that are needed for our application to run. Now, instead of building everything from scratch, we'll be using existing image that has Node.js, and all the necessary operating system layered into it, like it's all pre-installed. Now, this saves us a lot of time. Now, imagine having to build your own Node.js image before going on to now build the main newsletter image, right? So it's going to be stressful to do that. So let's as well make use of what Docker has to offer, like its built-in official images. Now, we're using Node 18 affine image because this is, of course, it's an official image, but this is the official Node.js image based on affine Linux. Right now, affine is super lightweight. It's a lightweight Linux distribution, and it's optimized for security and minimalism, right? So basically this, if I use the normal Docker 18, it's going to be heavy. It's going to occupy more space, right? But using the fine version means it's going to be lighter. Of course, there are some things that we would have to forego, but everything that needs to be installed into the node fine for our newsletter app to run would be installed, right? So let's go forward. The next command I would want to give Docker for instruction, I'll tell Docker this work directory or working directory /app. Now here we are setting the working directory inside of the container to be app. Right now, this means that all the commands that follow, like copying files or running commands, will be executed in this directory. Now, it's a good practice to set a working directory to keep things organized. And Docker will create this directory if it doesn't exist, right? Now, it doesn't have to be /app, it can be goodness, whatever directory you want to call it, right? But as a standard, again, /app is used. So I'm just going to go with that. Next, let's give Docker a command. Now tell Docker, copy the package or JSON, right? And it's copying it to the present working directory, right? So this line basically copies the packet.json file from our local machine. That's from right here, this packet.json file. It copies it into the working directory, right? This app working directory. Now, we're only copying the packet.json first rather than the entire application, to leverage Docker's layer caching. Now, this way, if you don't want to change, if you don't have any dependencies to change, Docker can reuse this previously built layers, to skip the installation steps. So let's imagine that haven't created I haven't created our image or our Dockerfile and we've run it and built our image from the Dockerfile. We made a mistake, right? But it had nothing or it has nothing to do with the dependencies that we've installed. Now, Docker works in a layer caching system where if it has run this is cached and stored. If it has run this is cached and stored. Unless there's something that directly alters this instruction, it doesn't run it again if you are doing a rebuild, right? So that's why it's important that this is happening. And the next command or the next set of instructions would be run npm install. Now, this command runs npm install. Now, to install all of the Node.js dependencies that are listed inside of this our package.json. So all of these dependencies right here would be installed. Let's get back to our Docker file. The next instruction we're giving is copy. Now, we copy the rest. Now we're going to copy the rest of the application. So basically we're saying copy all of this, right? Now this first dot right here refers to the current working directory of the local machine, which is this, which will be this in our case. I'll copy all of this on the local machine. And the second dot is the working directory that would be the working directory of the container, right? So we're copying it into the app directory on inside of the container when it's built. Next, would expose the ports for the container. So export. I'm sorry. Stay. Now, this line doesn't actually open the ports, right? But it's a way of documenting that our application is inside our application inside the container will be listening on port 3003. Now, Docker doesn't automatically map this port to the host machine. So of course, when we want to run the container on an host machine, we would have to map this port, right? Now generally it's best practice or it's good practice to use the same port that your application is running and expose it. It's best practice to expose the same ports which your application is running on. So let me explain. So in our app.js file, I haven't created everything. Hold on. Let's close this and push this aside so this can be bigger. Now, I haven't run everything. Our app is actually listening on port 3003, right? You can see that. So basically, I'm doing exactly the same thing. I'm exposing exactly the same port. So it's good practice to expose the same port so you don't get confused, right? Finally, would write this. Um, Now, we're using the CMD instruction as it's actually command if you think about it. CMD is command, right? We're using the CMD instruction to specify the command that should be run when the container starts, right? In this case, we're telling Docker to run node app.js because that's a set, which is the starting point for our application, right? So once this happens, the command will run when the container is launched, right? So we are done creating our beautiful Docker file. Yay to us. Now let's go on to building it, right? Let's build the image from this Docker file that we've created from this set of instructions that has been written down. So quickly, I'm gonna put this out here because now we're using this part. This is no longer that much important. I don't think we're touching any other thing here. I think this is great. This looks like a well-structured Docker file. Now Docker files can be much more complex than this, depending on your requirements, but this is standard. This is a basic way to build a Docker file. Also write a Docker file used to build a Docker image. Next, let's go into the Docker build. Now, we're going to be building the image in two ways, right? First of all, I will build it without the multi-platform option, then show you what it looks like on Docker Hub. Then afterwards, I'm going to build it with the multi-platform option and show you what it looks like on Docker Hub, right? So let's proceed. So Docker build. Let's target. So there's like a standard or like a way to tag your images, right? You'd want to use, especially if you are if you plan on pushing it to Docker Hub afterwards, it's best you use your um Docker Hub username, which mine is BusyBrainX99 slash the main name. So now, since we are building this newsletter app, it's a gym newsletter for gym rats like Johnny Bravo, to get the latest gist and best practice, best industry practice for working out, right? So let's call the newsletter application or Docker image. In this case, let's call it gym newsletter. We could give it a version. So we could call this the version 1 of our image, because I'm sure we'll be releasing other versions of the image when we have much more advanced builds. So now Docker build, yeah, I think this is fine. But the build context is this immediate directory. Now, again, with build context, the reason why I'm using these dots basically tells Docker to use the current directory as the build context, right? Is a place where um the build context basically should have access to both the Docker file and the application. Hold on, I forgot to do something. Sorry. There are stuffs that do not need to be in your Docker image, right? Or inside of your Docker image. So just the way you can git ignore stuffs, you can actually Docker ignore stuffs, right? For example, the node modules, when you run the npm package, it's going to install the node modules again. So there's no need having this here. So I can quickly ignore that by typing it out here, right? Um, Yeah. And since I am inside of the same directory as the node modulus, I don't need to put any slash this to that, right? It's node modulus. It's going to recognize and see exactly where it is and ignore it. The other thing I would want to ignore is yeah, the .env file, because again, the .env file contains some important information. Um That's the Mailchimp API key and also the server key. And I would not want that to be out. So let's imagine we're actually building this Gym newsletter image for it to be used by the public, right? Now, anybody that gets this image from my Docker Hub can easily pass in their own environments and variables, right? Their own Mailchimp key and their own API key and server key, right? But I wouldn't want anybody to have access to mine because when you build a container, you can actually, or when you build an image and you run it on a local system, you can actually access inside of it to see what's copied in it. So you don't want this to be out there, right? So you put it in your Docker ignore file. Yeah. So that's saved. We'll close this. So this is what we put. Now we can build the image. I think that's all. I think we're fine. Let me quickly look at the Docker file. Okay. I think we're fine. Yeah. So let's proceed. Now, as you can see, it's building. Hold on, we have an error. Um, the data from okay, I think that's in hurry. Let's look at what the problem is. Internal error load meter data for Docker. Okay, so when you run into errors, you don't need to panic. Um, Based on my experience, at least, I know that errors are part of programming or software development, whichever field you are, front end, back end, cloud. I've been lucky enough to build in all of these fields. So I know that errors are constant. So you just need to calm down and read the error message. Failed to solve. Okay, failed to resolve the source metadata for. Oh, I saw what I did there. I kind of spelled fine wrongly. So it went on looking for this wrong spelling. Hold on, I don't know why this is highlighting. So it went on looking for this wrong spelling on the on Docker.io library and didn't see anything called node 18 fine. So I think the spelling, there's no H, if I'm not mistaken. So let's take that out. Let's save. I think we should be fine now. I think this is the correct spelling of fine. Let's quickly clear this. Let's bring forward our command again to run. Docker build tag busy brain x99. Okay. Gym. Okay, I think we're fine. Let's build. We should be fine this time. Promise. Um, So because I built this image before, you can see that it's actually using the caged version, like the caged up data to build the image. And since no changes were made, that's the reason why we're seeing this. But I want to build this image from scratch. So normally this is a command that would be used to build the image from scratch. But since it's in the caged version, I'm just gonna pass in a command. But before I do that, let's clear this. Let's check our Docker images. Um, okay, what will happen? Docker, let's remove this image. Let's get rid of this. Okay, great. Now I'm going to introduce in a command, Docker build. I don't want the cache version, so I don't want the cache information. I want you to build it from scratch. So no cache should do that. Do the trick. Then still use the same name I used previously. Use the brain x99 slash gym. Um, later. Yeah, yeah. It should work now. Oh, well, that's as close as we can get to not using the cached version. So this is fine. So basically what it would have done was to get the image from Docker, which it has gotten. Now it would have created the working directory slash app, then copied the package the JSON file down to the working directory. Now it's running npm install. Then afterwards, it's going to copy the application, um, then build the image completely. So we're going to pause the video now because this takes some time to build, and we don't want to sit out the whole build process. So let's pause. Then we'll get back to the tutorial when this is all done, when this is all done or when it's completed. So it's done building. Again, if you are building this from scratch, you're not going to see this. It's going to take a longer time to build. I'm just stating that out. But if you followed exactly what I've done so far, you shouldn't have an issue. The Dockerfile should, of course, you might have run into the affine issue, the the thing with the H, but I haven't removed it. Your image should build successfully without any stress. I'm just stating that out. Um, Next, we can view the image with build. So let's clear this. Using the command Docker images, you can see that it's built up. Version 1 about a minute ago. Wow, that's huge for 61 MB. Um, let's check. Let's run the container. So we can run it using the command Docker, I want to clear this. I just want to get, okay. I know it's busy brain searching members. So let's keep this somewhere so I don't forget what exactly I use for the image name. Let's keep it out somewhere here. Yeah, just want to keep it here. Let's clear this. Now I won't run the image. So the command is docker run. Now, if this was on a registry, I probably pulled if I wanted to, if I didn't want to run the image first, I just wanted to have the image on my local machine. So I would have used docker pull on the image name, but I want to run it. So docker run. So I'm going to run it in the detached mode. Um, then I have to expose the port to my local computer. So I'm going to use for I'm going to use 3030. um, of course, tagging the ports are exposed on the container, which is 3003. Then my image wouldn't run properly or my container will run properly without my .env file. So I'm gonna get that, which is we can use this command to get that. Um, then the Docker image itself. So just gonna type it out. I think this is fine. I think we should be able to run our image. Um, hold up. Unable to find image. Oh wow. I made a bad mistake. So I'm running this in the detached mode. If I'm going to expose the port, if I'm going to like port forward, I should have the .-p option. Again, even if you've done this for a while, sometimes you can help or make some little mistakes or humans. So that's what happened there. So this should run now. Yeah, so it's running. So let's clear this. Docker, yes, this shows you the running container. So we can see our container is running, it's up and running, it's been running for 8 seconds. Let's look at what's inside of the container is, right? You can look at what inside of the container is within the interactive mode. Um, let's get container ID. Then running into shell. So now, as you can see, the starting point of our container is the app directory. As I stated, if I use goodness or goody, that would be what will be here, right? So now let's look at what we have here. As you can see, it copied everything except the node modules. As you can see, the node modules is new. This happened when the npm install was carried out or was run. If I checked for the .env file, it shouldn't be here because I ignored it. Sorry, ls-li. Yeah, so you can see that there's no .env file here. There's the git ignore, there's git that because I did not tell Docker to ignore those files, but the ones I told you to ignore, it completely ignored it. The reason why I see the node modules is because it's newly installed when I run the when this command run, it's going to of course install all of the packages and all it needed, right? So that's the reason why you are seeing it now. Yeah, so we can proceed. So let's check out our image, right? It's port forwarded on 3030, so we could go to localhost. Oh no, 3030. Your container, and we can see that now we are running. We're visiting the running container from our local machine. If this was on Docker Hub, someone else can pick up this container and run it on his own machine seamlessly. Now, this container would run on some machines and it wouldn't run on some. That's because it's not multi-platform, right? I did not make it, I didn't build it in a multi-platform way. So it might actually spin off some error or give us some error if this is run in a different OS that doesn't support what my computer uses. For example, now my computer uses the ARM chip 64 Apple Silicon, and if this was to run on a Mac OS using Intel or a Windows system, this would most likely not run. That's because the Docker container wasn't built that way, wasn't built for it. So quickly, I want to push this to Docker Hub, or should we? I don't think there's any need to push this to Docker since we want to make it multi-platform. So I'm just gonna exit the container. Then I'm gonna stop it. Again, I need a container ID. So I'm gonna stop the container. We're gonna rebuild this and make it multi-platform. Let's get right to it. For us to make the image multi-platform, we would need to use the command Docker Buildx, right? Now, the Docker Buildx is an extended build tool for Docker that enhances the standard Docker build capacity or capabilities. It allows for more advanced image build features or image building features, right? So it was introduced to address the limitations of the traditional Docker build command. So that's what we're going to use for the multi-platform build. So the first thing we'd want to do is to create this build profile. So let's call this Docker Build X create. Let's name it. Let's give it a name. Gym App Builder. Let's call it that. Right. So now let's make sure Docker is using our Gym App Builder. Oh, that's it wrongly. I think that's fine. Okay, great. So now we can use this to build the image, right? Now one thing that you need to know about building is that building multi-platforms that you have to push it to your Docker registry directly. So if you're not logged into Docker at the moment, you have to log in to your Docker account. The command is Docker login. If you're not logged in, it's going to authenticate your credentials, ask for your username and your password if that has not been supplied, but mine has been supplied, so that's why it's showing login succeeded. So now I can go on to building my my multi-platform image. Yeah, let's audit that. So Docker Buildx build or build. Yeah, Docker Buildx build platform. It's a command for multi-platform platform. Now this is what you use to make it multi-platform. Now you can say I didn't space it, so it's not spaced. So you have to. Sorry, that this shouldn't be it. AMD 64. I'm 64. Hold on. If I close this section, let me just save this. I want to make this. I want to expand this, make this bigger. So yeah. So tag the image next. No, as I said, you have to push directly, because if you do not push to your Docker of account directly, you would have to you can't actually save it locally, right? Because now you're having a multi-platform build, so definitely one version of it can't stay on your system, so you can't build it locally. The only thing that will happen is going to be caged in your Buildx profile, and you would not be able to use it that way. So if you're having a multi-platform build, normally, if I was going to build the image and I did not want to store it, I would have used load, but load wouldn't work in this case, right? Because again, it's multi-platform, so it will most likely not work. So again, I just advise, for simplicity's sake, just push it to your Docker registry. And let's not forget the build context, which is this present working directory. So this should build the application. and push it to my Docker registry account. Let's make sure the commands are correct so we don't run into any errors. I think this is fine. We're fine. Let's push. Wow. After wow. Wow, I guess to error human, right? Uh I can't believe I haven't looked at this command. I actually still made the mistake. It's not platform, it's platform. So let's build, we're building, pull in the image. Yeah, so again, this is going to take some time, so I would not want to sit out the whole thing. So I'm going to pause this video, then we're going to get back to the video when this is done building the Docker image. So this has been built successfully and pushed to my Docker Hub account. We can view it. Remember, the name is busy brain X99 gym newsletter version 1. Oh, so that replaces the other one that I just built. So if we go to repositories, you would now see that I have a new repository, right? And this is multi-platform, right? Of course, if you want to make it public, there are a lot of stuffs. Rather, if you want to make it public, there are stuffs you need to put on here, probably some explanation on what the Docker does itself. And you can have collaborators on on what the Docker image does itself. And you can have collaborators, and you can see here, I think somewhere around here, you should see that it's multi-platform. Yeah, you have both the AMD and the version, which means it can run um on different OSs. Just exploring the Docker Hub itself. Then of course, yeah, we can make it private, right? We can also make this repository private if we want. I think should go to settings. Yeah, make private. We can also delete the repository, stuff. So you could actually just go through Docker, but I think I might most likely do a special video on exploring Docker Hub, but this video is not for it, so I'm trying to make it as short as possible. I just wanted us to view the newly built image right here. So that's successfully worked. If I wanted to, now this image is on my local machine, right? If I deleted this image from my local machine, okay, first of all, I would need to get rid of, because I think if I run Docker RMI this image, I think it might not completely leave, or it might not leave. Let's see. Yeah, because there is even though there is no running container at the moment for this image, so you need to actually get rid of the old containers before you can actually remove the image itself. So I'm just gonna copy this, Genius layer, yeah. Let's get rid of this. Um that's also okay, I think that's just the one. Great. So I think I can use image ID instead of typing down the whole thing again. Yeah, so that will be deleted. So if I was going to pull from my Docker Hub registry now, considering I don't have the image right here, you see I'll be able to pull from my registry. So I can do, if I don't want to run the container, I just want to pull the image, I can see Docker pull. Let's go to my repository so I can copy the image itself. Yeah, so this is what I need to pull. The tag name is version 1. Yeah, and yeah, so it's going to be pulling. Oh, okay. Since This is a computer, I built it. Okay, some aspects need to be downloaded anyway, but you can see um it's pulling from my Docker account. So if you are doing this from a different system from mine, it will also pull. Doesn't matter where you're doing this from, as long as it's public on Docker, you can pull it and you can use it. Yeah, so that's it. Of course, I'll take down this image afterwards, this Docker image afterwards, but I just want to show you how you could pull your image, and it's also the same process to run, whether it's multi-platform or just built for one particular OS, as long as the image or the container supports your OS, or your OS is supported by the image, or your OS supports the image or the container, you should be able to run it the same way we ran it previously. I think that's just it. Okay, there's something I want to talk about quickly. It has something to do with build contest. People get confused a lot on build contest, and I said I was just going to address it shortly before concluding this video. Now, most times people build their Docker file on the same directory, or in the same directory as the application they're building. But there are certain scenarios where, okay, the complexity of the application might not permit you to build your Docker file exactly where your application build is on. You can actually build it in a different directory, right? Let's imagine that this is the pathway. Yeah, I think I will use a whiteboard for this to explain. Now let's imagine that the Docker file is here. It's in this directory path. So user, document, DevOps, Docker, then Docker practice or Dockerfile somewhere here, just within this Docker practice directory. And your application is on this directory path, for example. Right, the application is inside of this directory. Now, the way you build your file will be different, right? This would most likely be the command that you would use. Let's see if that's correct. Okay. Great, that's correct. So basically, the only difference is that now, since you are not building in just like this previous one where you are building in the same directory, since you're not building in the same directory, right? You would have to state the file path to the Docker file and also state the Docker file itself, right? Then you'd also you'd have to state the file path to the Docker file and also the Docker file itself. Then you would also have to state the build context. And as I stated earlier, the build context has to cover both the Docker file and the application itself. And it's a no-brainer in this case that the build context becomes user, documents, DevOps adventures, because DevOps adventures is what's common between the pathway to the Docker file itself and the application itself, right? So this becomes the build context. Instead of using dots that we used earlier, instead of using a command like this, where it's in the same directory, right? So the build context becomes a quite working directory, but in this case, you'd have to state the build context, and depending on what you're building for. And this example here is assuming that you're actually building from what do you call it? That you're actually building from the root directory, like you're building from the base directory. So what I mean is, if I was building from, let's say, this, right? So in fact, wherever you're building from, if you're stating your whole file paths, right? Because basically what I'm doing is I'm stating my whole file paths. This shouldn't be an issue, but assuming I'm building from this root directory here, then it will be easy to just state this way. I just want to state that build context, like where you put your Docker file, is important, right? And of course, if your Docker file is in a different directory from your application, then this file path becomes different, right? You would have to state the file path to the package.json file. And also, this wouldn't be the working directory, right? You would have to state the file path. So for simplicity, when you start building Docker newly, it's advisable to use the same directory for your Docker file and your application. Then when you get better using Docker, when you get much more conversant with it, then you can tweak, you can play around, you can even build much more advanced images with much more advanced instructions, because there's more to Docker files than this. This is just the base. This is just the beginning. This is just like I can call it an intro into Docker. Yeah, so I just wanted to get that out of the way. Well, to wrap up, we've built and run a Docker image for a simple Node.js application, right? And we've covered how to build a multi-platform image that works on both AMD 64 and ARM 64 systems. Now, whether you're running your app on a typical PC or an Apple Silicon PC or even a Raspberry Pi, right? Docker makes it easy for you to package and deploy your application across this multiple platforms. It makes it easy to deploy application across multiple diverse platforms, right? You can do that. Now, I hope this has been helpful. I hope you're able to gain some knowledge, something new, something different from probably other tutorials you've watched on Docker. I just want to thank you for watching and staying with me to the end. Now, if you have any questions, you can either drop them in the comments below. I'm actually very interactive, so I would reply. Or if it's something that's private, you can reach out to me via LinkedIn or Twitter. My links will be dropped within the video and also within my channel. So don't forget to like, share, and subscribe for more DevOps tutorials.